I'm going to explain how you draw a calibration curve in Excel. This is something that you want to do in all sorts of different circumstances, wherever you've got a range of concentrations and you've read the absorbance values for each of those concentrations. Usually you want to do this because you have an unknown or more than one unknown with an absorbance value, and you want to work out what the concentration is. First thing to think about is how you blanked the spectrophotometer. So if you blanked the spectrophotometer on your zero sample and set that reading to 0, you don't need to do this next bit. But if you didn't, and it doesn't matter which way you prefer to do this, let's imagine that we didn't blank the spectrophotometer and that we actually had a reading at this concentration. So I put a value in there. In that case, I need to subtract that value from each of these. So I'm going to use Excel to do this, and I'm going to type a formula equals and then the cell that I want to subtract from and the value that I want to subtract, which is 0.005. So that's my corrected absorbance value. I can now type the same formula in each of these cells, but I don't have to. I can just grab this little square and pull it down, and Excel will do those calculations for me. Now, I prefer always to blank my spectrophotometer, so that wasn't the way I did it. I'm going to delete those values and set that back to 0. It's important that you choose the right type of graph. And so I'm going to select the data that I want to draw a graph with, and then I'm going to go to Insert and Charts. And I want to use this scatter chart, and I do not want to use this line chart. Okay, so we'll go to the scatter chart, and there we go. I've got my basic graph. I prefer my graphs to be a little squarer. You can make all sorts of adjustments to this. One that you'll probably want to do is to remove the chart title. You'll notice if you look at academic papers that we don't use chart titles. What we do is to write a figure legend, which is underneath the chart. The other thing that you definitely do have are axis labels. And there are many ways of doing things in Excel, but an easy way is to click this plus and then click here for axis title. So I've now got somewhere to label the axis titles. The x-axis, I want to label concentration micrograms per mil, and I'm just a bit too lazy to type that out in full, so I've copied it. Click on the axis title and paste that in there. You'll notice when you do that that you lose the superscript on the -1, and the way to fix that is to then go in, select the -1, font, choose superscript, and we're sorted. And I also want to label the y-axis. This one's a little less fiddly to type, so I'm going to type it out. Absorbance 595 nanometers. Okay, I've got my basic graph now. One further thing that you might want to do is to add the minor grid lines. I'm going to do this by simply right-clicking on the numbers, and then it offers me this add minor grid lines, and I'll do the same thing, right-click on the number, add minor grid lines. So now it looks more like a piece of graph paper. You can see the faint lines as well as the major grid lines. And the reason you might want to do this is that if you want to read this value off, then it's going to be hard if you have to estimate where it is between 0.1 and 0.15, and the minor grid lines will really help with that. Okay, I'm just going to draw myself a straight line to use as a ruler. There we go. So you can see, I think you'll agree with me that our data is quite linear over the first part of the calibration curve, but that these 2 points really don't fit on this straight line. And that's really important. Have a look at your data. I'm just going to park that straight line out of the way for the moment. So if I ask Excel to draw a line of best fit through that data, it will do so. I've clicked on the graph, I'm choosing this plus, I'm going to trend line, and in fact what I'm going to do is click this little arrow and choose more options. So you can see that Excel will do what you ask it to. It's put a trend line through those points, but this is not a good representation of the data because this is not a straight line over its entire length. And if you try to use this straight line, it's going to be, well, you're going to get quite inaccurate values. So I'm going to get rid of that. Try and get rid of it. Here we go. Now, if you're drawing your graph by hand, that's fine. You can just get out your ruler and draw that straight line in. But if you want to do it in Excel, you have to be a little bit clever. And in fact, what we want to do really is to plot just those points, the ones over the region where the relationship gives a straight line. So to do that, I'm clicking on my graph and I'm again right-clicking and I'm choosing this option, Select Data. And this allows me to add another series of data. Don't worry about what it's doing to my graph. It doesn't really matter what it's called, but it matters that I choose the right value. So I'm clicking here to select the X values. So that will be those ones. Click this little arrow again, and now I'm going to choose the Y values, and that'll be those ones. And I'm going to click OK. And I'm just going to click OK until we get out of that. So now you can see the orange points, which have been superimposed over the blue ones in the region where we've got a straight line relationship. Now, if I select just those orange points by clicking, I can now do the same thing again and ask Excel to draw in a trend line. Again, I'm going for this more options. So Excel actually has a number of different trend lines it can add, but in this case, we're perfectly happy with a linear one. You can set the intercept to 0 because you know that that first value is a true 0. And you can also ask Excel to display the equation on the chart and the R² values. I'm going to do all of those, and then basically we're finished with this. Close it down. So let's have a think about what these values are. First of all, the R² value. So this is a statistic which tells you how well that dotted line, the trend line, represents your values. Because I made this data up, I have a perfect R² value of 1. You wouldn't expect it to be quite that good. And then we have this formula, y equals 0.0068x. So this is basically the formula for a straight line, y equals mx plus c, but we don't have a plus c because our line goes straight through 0. So we can use this formula in order to work out the concentration of our unknown. We need to rearrange it because we have the absorbance, which is the y value. And so we need to rearrange it basically so that it says x equals y divided by 0.0068. So that's the formula rearranged. So I'm going to use that formula to calculate the concentration of this unknown. And again, I'm going to use Excel to do it. I'm going to type an equals because I'm doing a calculation. And this is the y value divided by, and I'm actually just going to type the 0.0068. Okay, so it's giving me a value of, in fact, 16.47 to a lot of decimal places. You really should think at this point, how many decimal places does my spectrophotometer read to, for example? And it's certainly not appropriate to report it to 16 to whatever we've got here, 6 decimal places. So you can correct that. Where are we going? Yes. So I'm using this button here, which will simply reduce the number of decimal places. I think I'll go with 16.47. You can do a sense check to see if that value seems to be about right. You could read it manually off your graph. 0.112 is going to be about here somewhere, which is indeed going to give you concentration of about 16 micrograms. And you can also look to see that this value 0.112 falls between these two values. So you'd expect your concentration to fall between those two, which indeed it does. One last thing to think about. What happens if your absorbance is actually a bit high, let's say 0.275? So you've got a formula for a straight line, and you can do the same calculation here. In fact, we can do it just by pulling that down. And does that give you a good estimate of the concentration of the sample with an absorbance of 0.0275? The answer is no, it does not, because we know that the relationship between absorbance and concentration is not linear above this point here. So that is definitely not the way to go. I'm going to leave you to think about what you're going to do experimentally to allow you to read a value for this sample, which is more concentrated than the top values on the linear part of your calibration curve.